video, we're going to calculate the area between the x-axis and the curve. Before I do that, I'm just going to take us back to some definite integrals. So I'm actually going to work out the definite integral of this function here, and we'll go from 0 to 2 of x squared minus 4 with respect to x. Now when I integrate that, I get x cubed over 3 minus 4x. And because I said I wanted to work the definite integral out between 0 and 2, I'm now going to substitute those values in. So that gives me 2 cubed over 3 minus 4 times 2, take away as a 0. And work that out, we've got 8 over 3, which is 8 over 3 take 8, which is 24 over 3, and then I'm taking away 0. Now if I work out that definite integral, I get 8 take away 24, so where can I write that? Okay, I can write it here is minus 16 over 3. What you notice here is when we calculate the definite integral, we get a negative answer. And I purely want to go now and look at the curve. When we look at the curve between 0 and 2 of the line, or the curve, apologies, x squared minus 4, we can see that just this part here, obviously there's more of it, but we're just looking between 0 and 2. This part is below the x-axis. And so if I was to change that question and say I want to work the area out between the terminals 0 and 2, well, we can't have a negative area. So you'd need to find a way to combat that. Now in this case, I know that I'm working out the area, so I would change this sign. There's other ways you can do that. You can actually work out the integral between 2 and 0 by switching those terminals. The automatic answer will come out positive. You could also put a negative in front of the integral before you did that calculation. So you're going the negative between 0 and 2 of the function x squared minus 4, and this negative with the answer that came out negative would turn that to a positive answer. So let's do a question where we have a combined area to work out between the curve and the x-axis, where part of the area is below the x-axis and part's going to be above the x-axis. I'm going to stick with this same function. I'll just clear some space. Alright, so I've added an extra part to my diagram, and I've decided I'm going to work out the area of the function x squared minus 2 bound by the x-axis and the terminals, on the curve, and the terminals 0 to 4. Okay? So as you can see, the part between 0 and 2 is below the x-axis. So when I set up, let's say A for area, when I set up my definite integral, I need to say that there's a minus in front of it to combat that, and I'm going to go from 0 to 2 of x squared minus 4 with respect to x, plus this area here. And this area goes from where it cuts the x-axis, which is 2, to 4 of the same function, x squared minus 4 with respect to x. This part is above the x-axis, so when I calculate this definite integral, I will get a positive answer, so I just leave it and I'm adding these two together. So let's integrate. We already know that the integral of that is x cubed over 3 plus 4x, and I'm going from a minus in front of it because I'm doing this, from 0 to 2, plus, and then this one, same integral, but I'm going with different terminals, and that's going from 2 to 4. Okay, so I'm going to use all this space to work it out. I'm going to use some big curved brackets to work this bit out, and I'm going to sub it in. So we follow the same steps, sub 2 in. Okay, well I could repeat this, but I know my answer is minus minus. Let's put a minus in front of it. So it's going to be minus 16 over 3, so I might as well put that in, seeing as I've already worked that bit out in the previous part. Save myself some calculations. So I'd obviously write what I had in the previous example there, plus, and then we do this one. So I'm going to sub 4 in now, which is 4 cubed over 3 plus 4 times 4, should be 4, apologies, take away, and now I'm going to sub 2 in, so 2 cubed over 3 plus 4 lots of 2, and close that curved bracket there. Okay, now we can see here that the answer to subbing this in gave us a negative, but we have the negative on the outside, so that bit equals 16 over 3. Is that still writing on the video? Yes, it is 16 over 3 equals, and then let's work this bit out. let me just 2 seconds. I just wanted to check it was writing. So this bit here, this is 16 over 3 minus 8 over 3 plus another 8, which is another 24 over 3. So let's add 16 over 3. Alright, I realise now that I've put a plus sign all the way through here, look, and made a mistake. Apologies for that. So if you've been watching my video, you're probably thinking, whoa, what's she doing with a plus sign there? Okay, I'm human, I do sometimes make mistakes. So all the way through my integral, there should have been a takeaway sign all the way through. So that now makes the 16 over 3, which is now where I made that error. So let's correct ourselves. So here, I've got minus, so let me double check this. We've got 8 over 3 minus the 24 over 3 makes that negative 16 over 3. So I have 16 over 3 plus 16 over 3, which is 32 over 3. And then I've got to add a 16 over 3 altogether, which gives me an area of, it's not great because I'd normally write it underneath, keep it nice, 48 over 3 square units. Now we can move to square units because we're working out an actual area. So just to summarise, when you are working out the area between the curve and the x-axis between some terminals, you need to check with a sketch which part is below the x-axis and which is above. If you have an area that you need to calculate below the x-axis, we need to make sure that we make that into a positive area by changing the sign at the front of the integral. And that's pretty much everything you need to know about finding the area between the curve and the x-axis.